I'm Drew. Hey everyone, I'm Drew along with Kat, Naomi, Davin, and we have researched the impacts of light pollution and more specifically its effects on corals and coral reefs. So coral reefs are some of the most biologically diverse ecosystems on Earth, host to an incredibly intricate system of many different coral species. These corals are in constant degradation due to anthropogenic effects, one of which is artificial light that shines at night, abbreviated ALAN or ALAN. And ALAN originates from overly lit and powerful street lamps, hotels, office buildings, and more placed near the coasts. As we can see, this is perfectly demonstrated by the Gold Coast in Australia. This kind of light pollution causes the natural biological rhythms of corals that depend on lunar illumination cues to become disrupted and desynchronized, altering their behaviors, reproduction, and overall physiology. And due to the inherent human nature of building civilization near the ocean and bodies of water, a majority of the world's population lives near the coast. Marine ecosystems belonging to these coastal regions, such as the Nile Delta shown here, are at a higher level of risk due to the increased infrastructure required to sustain such a population. ALAN is a very pervasive and growing problem, as over 22% of coastlines worldwide and 35% of marine protected areas are affected by it. Incredibly diverse marine habitats, such as those which corals call home, are especially vulnerable to the potential impacts of the disruption of natural day and night cycles. At a rate of spread of 2% per year, in terms of areas lit and radiance to the light itself, something must be done about ALAN.
So anthropogenic activities produce significant amount of light pollution, especially ALAN. So they negatively impact coral by interfering and changing the early life stages of coral. And corals are the foundation of coral ecosystems. They are sensitive to the slightest change in light type and light intensity. Coral are governed by these natural cycles. So the Earth's orbit around the sun, the Earth's rotation, and the moon's orbit around the Earth. The lunar phases and the light and dark cycle regulates corals' biological processes and functions. As Drew mentioned earlier, their physiological, behavioral, reproductive systems. And then the light and dark cycle drives the internal biological clock of coral. When light pollution is emitted, it disrupts the natural cycle. It can block or amplify the natural light composition of the moons and stars. And then these irregular light dark cycles can mess up the cues that coral uses to synchronize and coordinate their biological systems, such as during reproduction, when to release their egg and sperm. The light pollution also affects the survivorship of coral. It changes the gene expression associated with this cell cycle. This includes the proliferation, growth, and survival. They're extremely sensitive to the white and blue light, which causes oxidative stress. And they have found that blue light is the most damaging to coral symbionts, and the stress contributes to coral bleaching. As we learned earlier, coral bleaching, what occurs is that coral expels the symbionts, and these symbionts are like their zooxanthins. They give coral their color, and then when they're expelled, coral loses their color, which you can see by the bleaching here. Then they turn white, and then they have an increased risk of death. The symbionts enhance the calification of coral, which increases their growth. When light pollution inhibits the repairability of coral because of the symbiont's photosynthetic process. And then these symbionts require complete darkness to function. So when they're not able to repair, it degrades the coral reef's quality. And then essentially light pollution causes the stress. And then the coral boots out the symbionts trying to save itself. And then the change or loss in symbiont density increases the risk and can result in coral death.
So light pollution has become an increasingly important stressor to be aware of over the years. In general, studies have shown that the amount of artificial light on land is continuing to increase at a rate of 6% per year globally. And moreover, almost no organisms can be found to be immune to this form of pollution. So this means that light pollution is a global problem that affects all life forms on Earth. Climate change and other environmental stressors, such as human interference, can also add to existing effects from light pollution and accelerate photoinhibition. In addition to this, coral are also subjected to severe degradation each year, which can contribute to disrupting the food web and biodiversity that coral reefs support. So this can lead to ecosystem dysfunction and ultimately come to impact human health as well. As the global human population grows rapidly each year, light pollution increases as well. Coral are essential to supporting a wide variety of organisms, many of which act as important resources for humans. Yet over the past few decades, as many as 75% of the world's coral reefs are threatened, and as many as 95% may be in danger of being lost by the mid-century. And so as they already undergo degradation from various other climate and human activities, light pollution will continue to severely impact not only the health of coral, but also the future coral reef, future of entire coral reef ecosystems located near coastal urban areas, unless action is taken.
On a local scale, the main issue to preventing light pollution in our oceans is a lack of incentives for local governments and cities to take the issue seriously and to actually dedicate resources to solving it. The slide shown is of a company called the International Dark Sky Places Program. They're set up all around the world and they work on educating small communities and public parks on the negative impacts of light pollution. This program specifically has a two-step plan to help combat light pollution on a local scale. Their two-step approach involves first increasing awareness of the benefits of the night for all living species, including aquatic corals in this situation, and then educating the public on how detrimental and urgent light pollution is to the species' health. Then by educating the public, they work with municipal governments to implement their certification program and make sure they're taking the necessary steps to avoid pollution. Switch. On a global level, we can see in this graph of irradiance at wavelength that there's a large spike in the 430 to 450 nanometer range called the blue peak. This matches research showing that the blue light shows the greatest ability to penetrate water at significant depths. A global solution to this would be to manufacture and regulate using lights with lower Kelvin ratings and longer wavelengths of light instead of typical LED lights used today that are capable of penetrating deep into our oceans. While making these changes would be quite helpful in reducing light pollution, we would also require a biological monitoring program to determine just how effective these strategies are over time and if there's any issues that arise as a result of these implemented strategies. In order to do this, working with programs like the UN Convention on Biological Diversity would be very helpful, as this would ensure if and where our efforts may need correction, which in turn simplifies and narrows a path to correcting the issue. In conclusion, if we do nothing, many environmental changes and anthropogenic threats that corals face will continue to lead and increased rates of species extinctions, ecosystem alterations, and degraded ecosystem function globally.